speakers, Simon Klint Berger, who is joining us today all the way from Malaysia, alongside Akmal Hafizuddin, also from Malaysia. Our first speaker, Simon, is the head of EPAC, and he co-founded COBOD International in 2017, which develops and produces construction 3D printers that can produce buildings and building structures. He is an experienced engineer within the mechanical or industrial engineering industry. However, his work towards sustainability in construction landed him in Forbes 30 Under 30. Our second speaker, Akmal Hafizuddin, is a co-founder of KA BINA, the first 3D printing company for construction in Malaysia. He's had an impressive track record that involves digital transformation, innovative tech, and entrepreneurship, which leads to his position in KA BINA today as he focuses on the company's strategy and finance. Simon Hoon will be easing us into the webinar today as a moderator later during the Q&A session. Shaun was selected as the founding curator of Global Shapers in Brunei by the prestigious World Economic Forum, and since then founded Curious Mind to connect thought leaders and change makers from around the world with the local community to inspire growth through digital media and conferences. With that being said, I am sure that we are in good hands today, so drop your questions in the chat and they will be addressed during the Q&A session. Final notice that there will be a photo taking session at the end. And now without further ado, we shall start with the webinar. The floor is yours, Simon.
Thank you so much. Is sound going through clearly? Great. Thank you so much for having me. I am truly honored to be able to speak for you here today. So I'll give you a little bit of an introductory to what we do at COBOD and our technology, and hopefully that will bring some interesting discussions later on with Shaun as well. COBOD International. We're a construction 3D printer company. You can see a brief version here of it. I think the image was just great, so I wanted to start out the presentation with this one. So basically, it's big 3D printers that we put on site to build houses. So if we just go through what I'm going to go through today, a short introduction to who we are and what our product can do. Then we will look at some product examples, so products that come out of our 3D printer. These products have been done throughout the world. I have a couple of examples from Europe with me, and I'm sure that Akmal will show something more local afterwards as well. Then we're going to talk a little bit about the benefits of choosing 3D concrete printing and COBOD. So just want to start out with a little video here to gain your understanding of
what if your next building came to life faster, better, cheaper, more sustainable? At COBOD, our mission is to build smarter through multifunctional construction robots based on 3D printing technology. Our vision is to automate minimum 50% of construction processes on building sites around the world. We partner with our customers, suppliers, and with academic institutions around the world to build a future-proof, modular, and scalable 3D printing and multifunctional robotic solution based on an open-source material strategy. COBOD is headquartered in Denmark with regional competence centers in the US and Malaysia, plus distributors and customers on all continents. COBOD key shareholders include iconic giants like General Electric, Perry, and the world's largest cement and concrete manufacturers, Holcim and Cemex. We printed Europe's first building in 2017. Since then, customers using our 3D construction printers 3D printed the very first 2- and 3-story buildings in Europe, US, and India. And COBOD 3D construction printers are now active on 6 continents. We've sold the largest number of printers globally for a variety of building applications, not just for residential houses, but for commercial, educational, industrial applications, and even wind turbine bases. We do not come to work just to make a living. We are here for a purpose. 3 billion homes are needed in the coming decades to meet population growth, while conventional construction prices are rising, making them unreachable for people that need them the most. The solution demands action and disruption, transforming conventional practices with tech-driven, efficient methods of automation. At COBOD, we're disrupting global construction in cooperation with our partners and our team of 100 professional pioneers made up of 25 nationalities. Our roots are Danish and merges an experienced senior management team with young tech wizards, plus a multicultural operational team ready to assist on the ground in multiple spoken languages. We dare to develop cutting-edge innovative solutions which optimize the value for our customers. We are thought leaders with our new state-of-the-art tech solutions, application areas and size, as well as our material innovation. Our exponential growth documents our customer satisfaction and centricity. Our continued success is directly linked to our customer satisfaction. We hold your hand all the way from training to installation, making you a world-class 3D printing expert and constantly ahead of tomorrow. We deliver a turnkey solution, including our printer gantry system, a mixing batch plant, pump, and our proprietary slicer software. Our machines are CE certified, giving you peace of mind. We deliver a future-proof solution. Today, a 3D construction printer, and tomorrow, a multifunctional robot, constructing much more than just 3D printed walls. And it can always be upgraded. Built on a modular and scalable design where you can always make it bigger and have more features. Use our website configurator and design your own printer. 3D printing gives you architectural freedom, round curves, smooth walls, better acoustics, and many other possibilities. COBOD uses open source materials. Use any locally sourced cement, sand, and aggregates. Our innovation has reduced material cost up to 90% compared to industry standards. We are disrupting the global construction industry to deliver less material waste, minimum labor needed. Only 3 people are needed on site. No one has sold more 3D printers worldwide and gained more in-market experience than COBOD. And we're just getting started. We are COBOD, world leader in multifunctional construction robots.
Also, for the ones that didn't see 3D construction printing before, I think just some moving images gives a better understanding of how it really works. So I hope it gave a good background. So let's go into the speak. So COBOD, we founded in 2017, as you could hear from the movie, basically made on 3 years of research in the market. So we went to 47 places around the world to figure out what is state of the art within construction 3D printing, to bring that information back to our Danish building sector. So at that point in time, we as a company were only focusing on plastic printing. What then happened was that we figured out everything was only been doing in academia. Nothing was done in real life in Europe. So we set ourselves the goal to print the first house in Europe in 2017, which we did successfully. And based on that, we got a lot of contacts that wanted to buy our technology. And that's basically the start of the journey we are on today. So today we're more than 90 people in COBOD, most of them in production and R&D, and then scattered out in our competence centers. We think it's very important to be out with our customers in the local markets. That's why I'm here in Kuala Lumpur, Malaysia, to be closer to the Asia Pacific region, together with Akmal in the same shared offices. So we sold more than 55 machines to this date. I think this tells 2 things, both that we sold more machines than all other competitors combined, but also that it's a very new market, right? When we can call ourselves world leaders based on 55 machines, you guys are looking into a very, very new market here, which is very, very interesting, and you're on the way to becoming first movers if you want to move into 3D construction printing. So regional offices we spoke about. So basically our focus at COBOD is the technology. We focus solely on getting the technology to as good a point as possible, meaning that our R&D team is actually the biggest team we have within the company. I think it's very important that our technology stays on top, and we address all the new ideas and features that our customers want. So that's why we partner with our customers instead. So instead of trying to do everything ourselves, from the material to building the houses, we understand our limitations. We're focusing on what we're good at, the technology, and we have world-class partners around the world, like KA BINA, Akmal, as you're going to hear soon speaking as our distributor for Malaysia. We have that around the world. Great, both material companies and construction companies and EPCs around the world to help spread out the technology, right? So as shareholders, you also heard we have General Electric, we have Holcim, Cemex, and Perry. All of them very important to us when we took them in was that they were actually contributing to the technology. And we only wanted to take in the shareholders as strategic partners also on development of the technology. So very soon you'll see news from General Electric. We're doing windmill turbine towers with them, with an even larger scale machine that's coming out for that specific application. So just a little bit about the technology here. We have our gantry 3D printer. It's a modular system. Every module you can see is every COBOD logo here is 2.5 meters wide. And this is the same for the x-axis, the y-axis, and the z-axis, meaning that you can build it up to the specification you need for your types of buildings. So if you're only doing smaller structures, you can go down to a very, very small configuration, which will, of course, make the technology cheaper to acquire. If you need a very big machine for doing on-site 3-story big villas, then we can do that. So the biggest machine we've delivered is 300 square meters, so 3,000 square feet in 3 stories. So quite a big machine. And then on the side we have our material delivery system, which is a material batch plant where it batches local concrete on site and pumps that up to the printer. I have another slide on that here because this is really one of the bigger advantages of our technology, and the reason why a lot of our partners choose to go with COBOD compared to other brands is that we use 99% local material. We understand that to make this technology feasible commercially in the future, we need to be competitive with conventional technology in terms of prices of building. This can only be done if we don't have a proprietary material and actually look into what resources do we have available in the local regions. So we developed a solution with this batch plant here where we're actually mixing the material on site. The only thing coming from COBOD is this 1% additive mixture, which is of the, I think Akmal can speak into that again soon or later. It only accounts for a very, very small portion of the overall price of the cement. 99% of the material is sourced locally. So your cement, your sand, and your gravel and water will be sourced from your local supplier, whoever that might be. So we're not married to anybody in that sense. We are totally open source. So just to tell you what that means, so basically we have 3 examples here and made with this new material technology. So I think the lower number, the bottom number here is the interesting one to look at. We have a building in Angola, in Africa, we have in Oman, Middle East, and Denmark in Europe. Really the material cost per cubic meter is the interesting one, right? And you can see for Angola, Oman, and Denmark, they are all quite low. Denmark is of course a lot more expensive. That's due to the general price as well, and Denmark is very high. But these are comparative to the RMC cost, so standard cost of cement in the region. So just to give you a comparison to that, so if you use a dry mix mortar, which all the other competitors are doing, you're probably looking at a 3 to 10 times more expensive material. So typically, maybe we could be looking here at $500 per cubic meter, which might be fine for a very, very high-end design. But if you want to do affordable houses and mass scale houses that are actually economically feasible, then we believe that this is very important. So let's go into a couple of examples of what has been built with our technology. I think that this Beckham project in Germany is really one of the pearls that was made very early on with our technology. So this was made all the way back in 2020. This build is interesting from the point of view that they try to use the form freedom of 3D printing to do two things. First of all, do a very architecturally pleasing design with these curved walls and round shapes that really is pleasing to the eye. And second of all, they try to incorporate as much as possible into the actual printing process, meaning that all the spacing for plumbing, electricity, and other features were actually printed directly into the system. So one example of that you can see here in the bottom is the bathtub. Actually, the foundation for the bathtub here is printed as well. What this left them with, which is interesting, is that the other trades, so the electricians and plumbers afterwards, when they came to the house and had to install the utilities, they actually saved 70% of time on that installation process because everything was ready. The conduits were ready, all the holes for plugs were ready. They didn't have to mill anything, basically because it was thought into the design process. Then when the house walls were done, it was already ready for these other trades to come in. Interesting thing here is to see the speed of build. Today we'll see a lot quicker houses being made, but this is of course very early. Also for Perry, this was the first house they ever made. What's interesting with this number of 38 days is that actually the first 28 days were used doing the first story, and the last 8 days were for the second story. And they are just the same sizes, and material-wise and printing time-wise, it should have been the same. But this just shows that a team, of course, when you get into the first time, you need to learn the technology. Once you master it more and more, you'll optimize on that. Next project is actually really showing that as well. So same team, also Perry. This is now, instead of 160 square meters in total, we're now speaking 380 square meters, 2.5-story apartment building that they built just after. Here they did 21 days in total for this whole building. So quite much showing that it really can optimize a lot on time when the team knows how to use the technology. Both of these houses are fully permitted from German standards, which are some of the hardest building codes in the world. So very pleased with that, and we see likewise all around the world that with the right work, building codes can be not circumvented, but the printing can be used for that, no problem. So just this learning curve that we spoke about was also very visible. On the left here, you see the first time we printed a house at COBOD. This was the first house in 2017, the one that started our journey, and our first machine, as you can see it here as well, doesn't look as interesting as the second one. But it took us 2 months, sorry, to print this building first time, because we had so much things to learn about material, about the mechanics, about how to build this house with this new technology. So 2 years after, we did it again with our new technology. This was already 3 years ago. We did exactly the same structure, exactly the same amount of material in 28 days. Did it over 28 hours, sorry. So over 3 days in total. So this is actually a 20 times improvement in terms of the speed, which is really impressive. And team today thinks that they can do this in less than 15 if they try to do the same again. But so that's very interesting to be looking at. And also all these learnings is one of the beauties I'll show you later, is that everybody joining the COBOD family and ecosystem now will be able to benefit from, of course, all these learnings. So third house here, this was actually the first one made with this concrete technology I was talking about with the local materials. I think it's a very, very beautiful build. They utilize the form freedom, and also they leave the walls raw inside. I think it gives a cool and rustic look. This is of course something you can choose as the builder. You can plaster the inner walls, you can plaster the outer walls, just as you do with a conventional building. You can put wooden structures or brick structures on the outside if you want it to look different as well. You should basically see this as a concrete wall, because that's what it is. That's what it is. Cool. So if you look widely at our technology and why it's interesting to be looking at using this for construction, we mainly look at 4 points, and these might be different for the different users of the technology, and there might be more than the ones I'm showing today. So we have automation, speed, sustainability, and design freedom. So in talking about automation, some of the key components here are that we actually put a robot up on site to build the house. So we lower the need for actual labor. That is good in a couple of reasons, and one of them is, of course, the less risk of accidents. One is that we get a better precision than man-made structures, because the machine is within millimeters of accuracy. So you will have, I mean, the way you draw it is the way you will have it, which also gives a lot of confidence to the other trades coming in afterwards, putting in windows, doors, conduits, and so on. And of course, lower cost in terms of labor as well. I think actually lower cost in terms of labor is not the most important part. I think it's the better precision and the lower accident amount, which are super interesting. So in terms of speed as well, you could see the learning curve from Perry and ourselves. Now we've actually come to very, very interesting speeds for building houses, meaning that you can build 50 square meter structures with 4 meters to the ceiling in less than 20 hours if you master the technology, which can really speed up the delivery of homes, which is a big problem these days with the amount of homes we need to get made. Sustainability also a very interesting point to be looking at. Everybody is talking about it these days due to our changing climates, and the building sector is one of the biggest contributors to the CO2 levels. So actually, because we open source material, you can mix in any type of recycled material as well into the mix. The first house we made in Europe was with 23% recycled roof tiles. So the red roof tiles that were crushed down, used as aggregates. Also, we have a lot of customers looking at using other binders than cement. So it could be geopolymers or likewise. So very, very interesting to see where this goes. And that's exactly what we want with this open source platform, is that people can use what locally makes most sense. And then, of course, at last, design freedom is a big advantage of the 3D printing system, as it is with metal 3D printing and plastic, is that you can, in X and Y axis, do any shape you want. So a rounded wall will cost you exactly the same as a square wall or a straight wall. In a conventional precast or built with brick manner, it would be a lot more expensive. Here it costs the same. So lastly, I just want to show you our world map here of where we have customers. If we just turn all these customers into knowledge hubs, because that's exactly what they are. All these places the technology is getting used right now as we speak. Actually, we have a huge force, right? Because there's so many people in non-competing markets looking at implementing this technology and learning as much as possible. So that means that we have a lot of people that are willing to share knowledge and information. So basically what we have made is a forum, knowledge base, and academy called COBOD Connect. And all these are made so that all the new customers will have less of this learning curve, and also so that the full capacity of all our users out there will be reached even faster. So that was it from my side. Thank you so much for listening in. I hope it gave some good ideas of what we do at COBOD, and then I'll look forward to all the questions in the Q&A session later. Thank you.
So our next presenter will be Akmal. Akmal, are you ready?
Brilliant. Okay, first of all, Assalamualaikum warahmatullahi wabarakatuh. A very good morning. I bid to the host of the event, Her Excellency, as well as Simon and the participants of this event. I'm very honored to be called upon to have this talk with you guys. So basically sharing the 3D construction printing, or we call it as 3D CP, implementation for Malaysia, Singapore, and also I could be talking about the region's adoption of this technology. So first of all, my name is Akmal. I'm the co-founder of KA BINA consultancy group, whereby we brought in COBOD's technology to Malaysia. Now, before anything, I would like to start off with the origin story of KA BINA. Where did we come from, right? Now, the story of KA BINA started off back in 2020, where we started to, a group of 4 co-founders, which is a group of my friends. We sat down and we wanted to tackle affordable housing issues. Amongst other issues that are faced in our country, we've identified that affordable housing is one of the issues that we would like to tackle. Now, simply coming up with another construction company, wanting to tackle this issue head on, we figured, why not? We try to adopt latest and new and advanced technology to this issue, right? Because if you look at the statistics of, let's talk about Malaysia. There's a more than 1 million shortage in housing, and 100,000 houses planned to be built by the government to settle on the issue of affordable housing. Now, when we are talking about affordable housing issues, it targets 2 major groups of people. Number one are those under the B40s. The second one are those of the first-time homeowners. People such as myself, which are those who are, still fresh off the university stage, wanting to get into the working life. Trying to get a house nowadays is very difficult, right? So first-time homeowners, the B40s, this all accounts for the 1 million units of housing shortage that we're facing here in Malaysia. And not only that, we saw that there's the opportunity and initiative by our local government to try and build more than 100,000 units of house to accommodate for this demand. So as I was saying just now, first, we wanted to tackle this issue of affordable housing. Second, we did not simply want to come up with another construction company wanting to tackle this issue head on. We figured, why not we adopt the latest technology in the market? So we were looking around, scouring around, looking at what are the potential technology that we can adopt. And we've identified 3D construction printing to be one of the methods that is growing in terms of its interest, in terms of its progress that it's made so far. And 3D construction printing is up there. So we've reached out to COBOD, and that's how the story started with KA BINA and with COBOD and our collaboration for this region, for both Malaysia, Singapore, and Brunei. Now, let's simply go through the additive manufacturing, or it's a scientific term for 3D printing in general. The growth of acceptance for additive manufacturing in the region is increasing rapidly over the years. And you can see that the forecast there is showing that there's a growing demand in additive manufacturing, whether it be in construction, whether it be in polymers, in plastic, in steel. So the growth of additive manufacturing is there in the ASEAN region. So looking at this, riding over on this growth, we see that 3D CP must be a component that is adopted by this region as well. Because as the understanding of additive manufacturing is growing in the market, it's only a matter of time that construction is going to be up there. Now, I think Simon has raised the same point that I'm going to say just now, which is on the benefits of 3D construction printing. Number one is, of course, in terms of its speed. Number two is on cost. Number three, in the labor requirement and digitalization, and of course, flexibility of design, the reduction of waste, and of course, mobility of the machinery. Now, these are all well understood, right? If you are very efficient, the caveat here is once you are efficient and once you've managed to identify the best ways to be utilizing the technology, then you can manage to achieve all of these benefits that are being highlighted. So this is just a reference point to the UK, because this is the only write-up that I've managed to find so far, a research done in the UK that shows the application of 3D CP in the market over there. Now, there's a reduction in terms of its overall cost to be 33%, and 37% decrease in the time taken to complete a unit of house. Now, the reason why I would like to showcase these results is because it is quite a reference which we believe is apparent in our first development of the 3D CP unit in Kuala Lumpur itself. Later, I'll show you some of the images of the first 3D printed house that KA BINA has printed last year. So these statistics holds its ground on what we believe can be achieved with the house that we've printed so far. Now, so we well understood, right, where KA BINA comes from. It stems from the need to try to tackle affordable housing. We've identified 3D construction printing to be the best method to go through with it. But now you might ask, right, why COBOD? You know, I can well say here that there are other 3D CP providers out there in the market. You can Google. There's Apiscore from US. There's Icon from US. There's Winsun from China. There's Saibi. So all of these companies that are trying to make up their name on the 3D CP market globally. But why we decided with COBOD? Now, this is a very important aspect to understand, because it will shape the way our clients in the region is going to view this technology. Number one, I think the most apparent reason for this, which I have yet to include inside my slide, is definitely the open source in terms of its material. Now, with COBOD's machine or with COBOD system, it is material agnostic, meaning that the local materials that you have are the ones that you will be using with the machine, which is not the same to say for other suppliers. For example, Icon, if you buy their machine, you must buy their material as well. So, you know, same goes with Winsun, same goes with Apiscore. So all of this accounts for the increase in price, right? So you can imagine that if you have to buy the machine, then you have to buy the material from them as well. And they are not locally made at wherever you are stationed at, right? It's from US, it's from China. So getting the cost to be transported here is expensive. So cost-wise, so you are going to save a lot in terms of materials. So that's why we went with COBOD. Number two is, of course, they have the largest presence in the market. They have strong backings from large companies such as General Electric, such as from Perry. You know, even for Perry, it's a good sentiment to point out, right? If you know, Perry is the largest formwork provider in the world, meaning that with using 3D CP, right, you are practically eliminating formwork, right? So why is it that the largest formwork company wants to invest in a company that's actually their competitors in a way? It's because, you know, if you can't beat them, you join them, right? So that's where, I think that's where it stems. The idea of Perry wanting to invest is actually a good allegory to what's going on in the market today. So I think, yeah, and I believe so that the strong backings of all these giants what convinced us to adopt this technology here in Malaysia, Singapore, and the region. And also they are the developers of the fastest printers in the market, able to print, I mean, at its maximum capacity, which is very dangerous. The printer can move up to 1 meter per second. So if a machine of that size moving at 1 meter per second, one hit, you will die, definitely. So it's very dangerous to be operating at such speed. However, I mean, it is a testament that the machine is capable of going very fast. Next, I mean, just to highlight some of the success story from COBOD is, of course, again, as I've mentioned, they have strong backings from Perry, General Electric, Holcim, Siam Cement Group is also in Thailand, and also Cemex from US. And then these are, again, some of the examples of success stories from COBOD around the world that you can find online. So just Google COBOD, you will definitely find all of these success stories for testimonies. And not only that, they have, you know, again, presence all around the world, right? For example, America, in America, you have GE, Perry in Germany, Saudi Arabia, Dar Al Arkan, UAE, H.E Ar in UAE, and Lafarge Holcim from France. And yeah. Next is, okay, now let's talk about this region, right? So for KA BINA, we are stationed for both Malaysia and Singapore. And you also have Siam Cement Group from Thailand, JGC from Japan, L&T from India, Bakri and Brothers from Indonesia, Vietnam is coming up, and Fortex from Australia. Now, it goes to show that the adoption of COBOD's printer or this technology is growing widespread, right, in this region. So Thailand pun baru dapatkan their printer, Japan, JGC, which is a very huge company. I mean, all of these are very huge companies, right? I'm sure you guys might know, those who are from the contractor or developer background, you know of these names from all around this world. So it goes to show that companies everywhere in this region are starting to adopt this technology, because this is the future. This is what KA BINA and COBOD believes to be the future of construction. And we have to start now, definitely. Again, these are some of the examples of the global projects. This is one of the very impressive printing that's currently ongoing in Texas by Perry. It's a very large 4,000 square feet home, developed with very unique designs that you can see in terms of its structure and printing capability. This is again another example of a design that was printed, an office area for Perry over in Austria, completed within 45 hours. And also, I think Simon has mentioned this one. It's completed. It's actually the first concrete printer that's that uses concrete material to print the house. This is from Angola, Africa. It's actually completed in under 8 days for the whole structure.
Wow.
This is from Africa in just 18 hours, 14 trees, and Geotech as well in Oman. And an interesting fact that I have yet to include inside my slide, because Geotech just announced last week that they've actually printed 3 structures over 8 days. So you can imagine they printed one cafe of about 800 square feet in under 3 days, and then a toilet structure in 2 days, and a house unit for a fisherman over there over in the next 3 or 4 days. So in total, they've managed to print 3 structures in just under 8 days. Now, this is done by a research institute, nevertheless. It's not even a construction company. It's not even a developer that's working on it. It's a research facility that's working on that type of project. So it goes to show that with experience, you are able to produce more and more in under lesser time. So just to highlight some of the examples, this is a company from UK. They've managed to print this very simple structure in under 2 days, less than 10 hours actually. And I think another point that Simon mentioned just now, an example from Sarawak, which is very close by to Brunei, where you guys are stationed at, or where you guys are coming from, is actually in Brunei. So it's actually a company called Sarawak Consolidated Industries Berhad, where they've printed this house as a first 3D printed structure, basically, in the Borneo region, as far as we know, right? So they've actually completed this unit earlier this year, if I'm not mistaken. So yeah, I think again, it goes to show that the presence of COBOD's machines and the products developed by all these 3D CP players in the market is very close to where we are stationed at. It's near our doorsteps. So it's already here, right? Now, I'd like to show where KA BINA's progress is. As you can see here, it doesn't look as palatable as all the other structures that I've shown you earlier, simply because the designs that you're looking at here are actually the first structures that we printed. It was we've acquired this machine last year in August of last year, and that's where we had to do our material research, material R&D, because bear in mind, if you are to acquire this machine, the template recipe that was given is given by those customers that are from outside of the region that you're operating in. So actually we were working on this recipe that we got actually from Angola. So Angola has developed their material recipe over there that seems to work for them. We took on their recipe and we delved into material research, and we did our R&D to improvise, you know, to reduce the cement, to increase the water, just to make it viable for the local climate that we are operating in. So the structure that you're seeing here is actually our first printed structure with a working concrete material that's working with the machine. So that's why it doesn't look as pleasant. But definitely, we were very proud of the achievement. We've managed to get this structure done after 3 months of material testing with the machine. And we were definitely assisted by COBOD. They are material experts who were there to ensure that we achieve the success of printing this structure with a workable concrete material. Now, the house that I was talking about. So KA BINA is the first company, at least in Malaysia and Singapore, to be 3D printing a full-fledged house on site. So it was done. It was completed actually on the February of 2022 of this year. This is the architectural drawing for the house. And this is some of the images for the printing process that we've had. over in Kuala Lumpur. So the house is actually based in Kuala Lumpur. And for those participants that are interested to come over and to see the house, we are more than welcoming you guys. Just hit us up. No problem. We can bring you to see the house even. So this is actually the, once we are done with the printing, that's where we started to install the roof and the finishings and stuff like that. So this is the end image of the house that you can see over here. I think I would like to share a video. Can you guys see the screen now?
Yes.
All right. Just bring it up.
So that machine, 2 40-foot containers to come in?
Sorry, what was that?
I saw 2 massive containers that house the machine.
So yeah, that's basically from the shipping from Denmark. So we got the machine from Denmark, right? So as it was shipped in 2 containers. One container is where you get the printer set in. The other one is for the other machinery, the batch plant, the pump, and the silo. So that's why you have 2 containers being shipped in. Yeah.
Wow. And how big is this plant here?
How big is the what?
The plant, the size, the area size of your project.
Oh, the project. Okay, so basically this house is roughly about 1,400 square feet. So the space that we are working with is around that size lah. And the printer is actually our size of printer. I think Simon has mentioned it is modular. The size of printer that we went with our first order is a 553, meaning it is a 12.5 meter by 12.5 meter and 7.5 meter in height. So it means it's capable of printing actually 1,500 square feet, 2-story home. So that's the size of printer that we have lah. That's our first printer, and our second printer is also of the same size. So yeah, I think that's the printer that we have lah, in terms of its size. Yeah, so of course, this is the first structure that we printed. There are room for improvements, definitely. We are well aware of that. But in terms of its structural integrity, it has been verified by a local institute that goes and check on the structure of the walls, whether it's is there any compromise in terms of its structural integrity. There is none. So it has been verified. Although in terms of its finishing, it's not as nice. Again, bear in mind, this is the first house that KA BINA printed. Although we had a working recipe, trying to make for the efficiencies, to achieve the efficiencies, to make it look nicer, all of that requires more practice, right? And we believe with our upcoming project that we are going to do, we will manage to achieve those efficiencies that we sought for, definitely.
Congratulations, well done.
Thank you very much. Truly appreciate it. Everyone was quite amazed that we, a very small company capable of 3D printing this. And these are some of the images or the visuals of the house that we have. This is the interior, and of course, I think we can go through the an in-depth explanation about how the house is being made, what type of material that we use. Even the house is it's a load-bearing wall, means there's no such reinforcements at all for this house. So just bear in mind, I think an additional detail to share here. The house that we 3D printed is actually load-bearing wall concept, means that there's no reinforcement, there's no rebars, except for the lintel area. Means that for the doors, the windows, the top part of it, in order for us to get the support to hold the structure from the top, that's where you put the rebars in. But other than that, there are no rebars at all. And we've actually gotten a consultant to sign off on this design. So to the market that's concerned, right? I know some of you developers, contractors background, you must be wondering, boleh ke, ada ke engineer nak sign ni? Actually, yes, there are engineers that's already signed on the house. It's already gotten approved. In terms of its structural punya perspective, right? So that's where we are coming at lah. So that don't be too concerned about getting approval. You can get it, because again, it's not to say that if you are using 3D printing, you must go with load-bearing wall. You cannot have reinforcement. That is not right. So with 3D construction printing, I think the concept here is that it is simply another tool for you to develop or any concrete structures that you are thinking of. If, for example, your structural engineer requires you to have reinforcement, hence you can have reinforcement. One of the ways that I can demonstrate, if you want to have reinforcement in the house using 3DCP concept, if, for example, you're printing a simple 4-sided house, right? And for example, your structural engineer says you must have 4 columns at the 4 corners of the house. So the way you are going to do it, right? You would have the starter bar coming up from the foundation at all those 4 points, and the printer will understand that the locations of those rebar, the starter bar, from the design of the house that you will slice in the software. So they will know there are 4 columns that needs to have reinforcement in. And the way the 3D printer can go about printing is printing the outline or the formwork for the column all the way up. You put in your rebars and you simply pour concrete. Now that is one of the ways that you can achieve reinforcement with 3D construction printing. Just to clarify some of the questions that the audience might have later.
Brilliant.
So now I'll just go through the brief process of how 3DCP works, at least with COBOD's technology. First of all, it will start from the design of the house itself. So the design of the house is, you just need to prepare an architectural drawing from whatever software that you have, whether it be AutoCAD, Revit, or even SketchUp, right? Just for your information, which is very interesting. The first house that you saw just now was actually designed using SketchUp. So, it goes to show that the slicer software developed by COBOD is also agnostic in terms of where the designs are coming from, as long as you export it in a step file format lah. So then the printer will understand, okay, these are how many layers I needed and stuff like that. Now through the COBOD proprietary slicer, that's where you will know how many layers you need to achieve to complete the house. Number 1, how long would it take? And number 3, how much material do you need to complete the whole house? So all of this data you can get earlier on from the slicer software itself. Now bear in mind, in terms of material, you have to put between 10 to 15%, just in case if you have to work on the stuff like in terms of the material, how much is needed and stuff like that lah. So once you are done on the design phase, then you will move to site operations, where the first thing is, if you are using a concrete printer. Now, I think it's important for me to state here, with COBOD's technology, you can explore 2 types of material. One is concrete, the other one is mortar. Now, the difference between concrete and mortar is that mortar does not have aggregates, whereas concrete, you have aggregates. So if you are purely focusing on mortar-based printing, then you would not need to have all this mixed batch plan. You don't need the pump. All you need is a simple MTech pump, which is a smaller pump, which is cheaper, but you can only pump mortar. The downside of using mortar, also in terms of its upfront cost, right? Since I've mentioned just now, MTech is cheaper than having the mixed batch plant and the pump. The material that you will need to use is more expensive. Even the closest supplier of 3DCP mortar materials, which is from SCG, is actually more than 5 times expensive than the concrete that KA BINA is currently using. So that's something to bear in mind on when you are using mortar. But of course, when you're using mortar, you'll get smoother finishings, you'll get nicer finishings, it's easier to handle and stuff like that. But we as KA BINA, we find that moving forward, in order for this technology to be affordable, we have to explore concrete printing. And bear in mind, we are at the stage where we are more confident in using this material locally for this region, and it's concrete. So coming back to the story of the flow of 3DCP process, mixed batch plant is where you're going to mix the material. You will have 2 conveyor belts in the batch plant that hold sand and aggregate. You'll have another silo that contains the cement, and that's where you will key in digitally the formula for the recipe that you would like to achieve. then the machine will just mix based on the proportions that you have set inside the computer. It will mix, and the material will drop down to the pump, and the pump will push the material via a concrete hose. So you can imagine it's like a simple, the water hose that you have. Instead of pumping water, you are pumping concrete. So all the way to the printer, and the printer will start printing based on the design generated from the COBOD proprietary slicer software. So that's how the overview of the process of our 3D-CP works, at least with COBOD's printer. Now again, the machine is modular in size, as mentioned by Simon earlier, means that if you are going for smaller structures, then you can opt for smaller printer. If you would like to go larger, then you can simply install more modules. One module is about 2.5 meters. So you can add on to that machine to make it larger, to make it smaller, depending on what kind of design that you would like to achieve. So that's the beauty of the modular design of the gantry system provided by COBOD. Now, we've talked about where we are coming from as KA BINA as a company. We've talked about why 3D-CP. We've talked about why it must be COBOD. We've talked about the process, the end result or the product that has been generated by COBOD, by all of the developers around the world. We've talked about the process of 3D construction printing as a whole. Now let's talk about the end results that you can achieve with 3D-CP. I think this is very important to highlight to everyone listening today. With 3D construction printing, you are not just focusing on housing. So KA BINA itself, right? We've had a revelation of ourselves going through the journey of using this printer, and also talking to all of the relevant stakeholders from everywhere, that from regulators, from contractors, from developers, from research institutes. We understood that although the starting point for our company was affordable housing, that's not necessarily the only thing that you can achieve. It's not just housing. It's any concrete structures that you can think of. I think Simon has preluded you guys over the fact that GE is using the machine to build their wind turbine base. Now that's amongst other things that you can achieve with 3D construction printing. You can 3D print a bridge, you can 3D print concrete furnitures, and there's even an application for you to 3D print water tanks, oil tanks, storage tanks. All of it can be 3D printed. So that's where we started to look at the potential of 3D construction printing beyond simply doing housing. So, and also, just to give some of you guys the idea, using 3D-CP, we believe that you can meet some of the SDG goals due to the implementation of, if you're using concrete 3D-CP materials, one of the ways that you can achieve the SDG goals is if you are using recyclable materials as filler materials in the concrete that you are 3D printing, which makes for you to reduce the amount of CO2 emissions from the concrete that you are using itself. Now again, bear in mind, if you're using COBOD's printer, you are material agnostic, meaning that you are not reliant on simply one recipe. As I've mentioned to you just now, although KA BINA has come up with the first workable recipe for this region, it's not necessarily that any of the other developers or contractors must use the recipe that we've established. You guys can come up and develop your very own material, whether it be with recyclable materials, geopolymers, or any other materials that you would like to be used for your concrete developments. And these are another examples. There are 3D printed EV charging stations already. There's also, like I've mentioned, water tank applications, storage tanks for liquid that are being 3D printed. And also, just to showcase to you guys, this is, as I've mentioned just now, the way for you to achieve reinforcement with 3D printed structure. So you are printing the outline or the formwork for the structure that you would like to put the rebar in, and you simply pour concrete once everything is all done. So, there are the tanks and storages for liquid and gas. And again, GE's impressive project to develop the base of a wind turbine. And yeah, so where do KA BINA come from in terms of our services? We provide consultation. We are in the R&D process. We provide the raw material research, the 3D printer, technical support, training and delivery, and regional engagement. And as a company, what have we achieved so far? So we've invested more than 5 million ringgit to acquire both machines. And also we've invested more than 400,000 ringgit in terms of our R&D material development. We have actually 7 engineers to date. More than 8 local universities have reached out to us, and more than 100 companies that are interested in learning and wanting to acquire the machine so far for both Malaysia and Singapore. We have yet to have one from Brunei. So I'm actually interested to see if there's any Bruneian companies that are going to reach us out after this. And also through the progress that we've made, the investments that we've made earlier on, these are some of the achievements that we've made. We've managed to reduce clogging rate by more than 60%. The printer setup time was reduced by more than 40%. Cleaning time was reduced by more than 50%, and loading material is also reduced by 50%. Again, these are the efficiencies that you can expect once you are more familiar and more experienced in using the technology. It is with any technology in the market. Awal-awal, yes, you are going to face problems, but when you are familiar with it, you find a better way and more efficient way to go about exploring the use of the machinery. And these are some of the potential improvements that we can make to the technology. For example, there are the ready-mix concrete solution with 3DCP application that KA BINA believes that we can adopt, right? Because there are existing infrastructure that already produces RMC, right? But why not we tap into the already existing infrastructure for us to 3DCP, for it to be 3D-C-pable, so to make it 3D printable. So not only that, we can explore stronger and more reliable concrete material. There are mechanisms to have rail tracks for the machine, variable nozzle size, integration of other construction processes, which has been highlighted by Simon earlier on. It's not just a machine that prints the walls. Moving forward, you can expect the paints to be done by the machine, the plastering to be done by the machine, all of it to be done and taken over by the machine to build a robot, basically, at the end of the day. Now, what is our commitment, right? So basically, both KA BINA and COBOD are now working joint partners to assist a successful adoption of this technology here in Malaysia by having them on board to be in Malaysia. So I think Simon is the CEO of COBOD Asia Pacific. So they've already been stationed, they are stationed here in Malaysia to accommodate for the requests and the demands and the understanding for the whole region. So it's very near to Brunei as well. And these are, again, and other commitments that we've had. We've had our Minister of Works to come down and visit the house, the first 3D printed house in Kuala Lumpur. We've managed to nudge our Ministry of Works to develop a national level working committee to look into 3DCP for their project tender specification. We've signed an MOU with CIDB, which is Malaysia's local regulator for construction. We've also signed a few MOUs other than UTHM, Harriet Ward, Sunway universities on the way, University Malaya, and all of it we're signing MOUs for that. And we've all, as I've mentioned earlier, we've developed the first workable 3D printable concrete, and also we've printed the first 3D printed house in Malaysia. These are also some of the visuals that we've had. This is the Minister of Kerja Raya. This is H.E Ar. We have CIDB Malaysia, Ministry of Science, Technology and Innovation. We've had UTHM, Harriet Ward University coming over. And also we've had sessions with industry players, for example, Berjaya Group, Putrajaya Holdings, UEM Sunrise, UDA Holdings, MGB Group, Sime Darby, Green IBS, Siti, and all of it, right? So now, last but not least, I think this is the last slide for me. I think KA BINA, we aspire to develop the right partnerships with all of the relevant stakeholders in the market, because bear in mind, KA BINA alone, even with the support of COBOD, we cannot go anywhere with trying to nudge the market to accept this technology if we are operating by ourselves. So that's why we try ourselves, we pressure or we progress by having all of these MOUs to be signed by regulators, contractors, developers, and even research institutes. And I think it goes the same with any of the other players that are targeting to bring in this technology in their market. And it will be the same for Brunei as well, because in order for this latest technology to be adopted, there must be nudges or support by all of these relevant stakeholders. And that's why universities are very important, regulators are very important. And I'll just give a simple example of how regulators from other parts of the world nudging for this technology to be implemented. For example, Dubai have stated in their 2030 vision is to have about 15 to 20% of their housing development to be 3D printed. Again, these are the kinds of policies that can ensure that the market is more incentivized to be adopting this technology. Hence, we are starting the conversations with the market and also the regulators to ensure that perhaps, rather than focusing on IBS, which has been for a long time, right? IBS has been talked about for more than 20 years already. Now we have to shift for the technology of the future, which we believe to be 3D construction printing. So the conversation must start now. So the market must be able to accept and be open-minded to accept this technology now. And last but not least, KA BINA's aspiration, the reason why we brought in this technology now, because we do believe that this is the starting point of the technology. We want this region to be mature as with any of the other developed countries in the world. Right? We don't want the other countries to already have the head start, and then once it has already matured for the next 10, 15 years, then only, Malaysia, Singapore, Brunei, then only we wanted to adopt this technology. Then it'll be too slow already. So that's why having this technology here, now and today is what is important to ensure that we mature alongside all the other developers, and we can't do it alone. So that's why we are more than interested to have this conversation. That's why I'm very honored to be speaking to our Bruneian counterparts, and we are looking forward to whatever strategic relationship that we can have moving forward. And if you have any questions, I look forward to it in the Q&A sessions, and we are more than open to have the conversations moving forward. So thank you very much for this opportunity and platform. I'll revert back to the MC. Thank you.
Thank you so much, Akmal. I agree with what you said about how the conversation should start now. Thank you again for such a wonderful peek into how much 3D printing can contribute to the construction industry. I really look forward to hearing more later. We will be showing a video on Penjana, Productivity and Efficiency Joint Funding for Digital Adoption from AITI, which aims to encourage the adoption of digital solutions by MSMEs through financial funding to a portion of the solution's total costs.
Penjana scheme is a joint funding scheme and is open for businesses 100% local owned by Brunei residents and permanent residents. The business must be categorized under micro, small and medium enterprise. The business must be active and operational for at least 2 years. Eligible MSMEs who wish to follow the scheme will need to pay a minimum amount of 30% to a maximum of 50%, where the rest will be covered by AITI. The percentage depends on the annual turnover of the MSMEs. Just to highlight, the maximum subsidy provided by AITI will be 5,000, which will be made available for 1 year. To know more on this, you may visit AITI website.
Now I will pass the floor to our moderator here, Simon, to introduce our special guest speaker, followed by the question and answer session.
Hi, good morning. What an exciting morning that we've had. Before I start the moderating session, I want to bring on a special guest, Her Excellency Architect Siti Rozaimeriyanty, Her Excellency Yanty, if I may call you, who is the newly appointed Secretary General of AIPA, which is ASEAN Interparliamentary Assembly. So yeah, before I read on a short introduction, congratulations, Puan Yanty. You have done us proud, and we can't wait to hear from you. So here's a quick introduction of Ms. Yanty, along with her role as the Secretary General of AIPA. She is also the Director and Principal Architect from Bumi Architect. She was previously the first female president of HUJA, or Brunei's Institution of Surveyor, Engineers and Architects in 2019 and 2020. In her position as the Secretary General of AIPA, Her Excellency fully intends to work with both public and private sectors to realize shared goals for the future of ASEAN, Her Excellency has also shown a strong advocacy and valuable contributions towards Brunei's growth and development, particularly in terms of sustainability and innovation. In this conversation, we hope to tap into Her Excellency Yanty's perspective about 3D printing technology on its application for Brunei and how she sees the future of the construction industry in utilizing this technology to its advantage. So welcome, Ms. Yanty. I used to be calling you YB Yanty, and I understand that your new connotation is Your Excellency Yanty. So please forgive me if I'm a little bit tongue-tied.
It's okay. Hi, Shaun. How are you?
Good. We're excited to have you here on two main perspectives. Number one is, with your background as an architect, we want to seek your view on, how you see this new technology and its potential for Brunei Darussalam. In your capacity as, the Secretary of ASEAN Interparliamentary Assembly, what are your observations on, the application of this trend towards Southeast Asia? So which one would you like to start on?
I'll try my best to actually provide you with some of the questions. I know everybody's actually curious with this, and thank you so much, Simon, and also Akmal, for really sharing what your company actually has done, and it is, and Akmal actually rightly say so. It is high time that we actually start to look into technology. Construction is never an advanced kind of technology. We are always the bottom two in terms of using traditional construction methods. To actually change mindset is always not easy, but we have to actually give it a shot. But if you actually look to the fact that in terms of the global construction industry, and based on the International Energy Agency report in 2020, 20% of the carbon emission actually comes from the construction industry. And, based on COP26, what we're trying to do to actually achieve a zero carbon emission by 2050. So when it comes to sustainability, it's everybody's business, regardless which industry you're in. It is when it comes to climate change, it is everybody's contribution to play their role, what we can actually do. And again, even though concrete printing is new, but it actually has been done, it has been proven. From COBOD actually show the projects that actually have done. And we are really looking at green construction technology. And I remember last year when Brunei chair ASEAN, and among the 13 priority economic deliverables is to look into green economy. And again, we look into digital and we look into technology, and green technology is one of the things that we need to actually really push strongly and support this initiative, whether it's in Brunei, throughout Asia. Everybody knows that, with this concrete printing, it will actually lower the cost. It will actually, it's a rapid construction, so it is faster to build. It uses less wastage, and we don't use that much resources. Workers are also less, and during the COVID time, everybody have issue with regards to people working at site. Manpower is short. The increase in raw materials has gone up because of logistics as well. And we use less equipment when it comes to this. But also bearing in mind, when we talk about green construction technology, is really for people, the team, to adapt this. I mean, I'm sharing with you, Shaun, we are currently working on a 3D printing concrete for one of the surau in Temburong. So we actually are working very closely, and I'm actually glad Darussalam Enterprise actually bring in the team to work with. And we actually collaborated with APN Tech, which is based in Singapore, on this concrete printing as well. But like I said, it doesn't really matter which company. There's a lot of companies that are actually doing this. What's important is this knowledge transfer, how it can actually be adapted into individual countries. So when I actually had a meeting with them, again, this is only about 200 meters square, Surau, right? The first project, if it's actually going to be adopted or going to be commenced, because it is still in a very early tender stage. So it's going to be a Surau and for 50 packs, and it's located in Temburong itself. So it's going to be a green technology, and it's going to be a sustainable and energy efficient as well. So, but we also need to actually adapt in a way that the construction methodology is actually different as well. I mean, how traditional consultants work is, you know, your thickness of wall is about 150 meters. So you have your column, you have your beam. But when you actually work on this concrete printing, you're looking at perimeter wall that is thicker than normal. It is a load bearing wall, as what Akmal actually said, but it can actually be put together with, of course, the reinforcement bar. So you're actually using less reinforcement bar or zero reinforcement bar again. So you will, and you don't actually use any brickwork. So you reduce the loading of the building, which is actually even fantastic, because then you don't actually have to put too much of your piling works, you know, those kind of things. But the thing is, there's a lot of R&D that needs to be done. In Brunei, you will work very closely with, say, for instance, cement manufacturers. Yeah, so in Brunei, you actually have Butra Heidelberg Cement, yeah, which is also German-based with Brunei company, and they also have produced concrete in Germany. So again, you need to actually work with knowledge partners, and COBOD is one of them, and KA BINA is also one of them that you can actually really work with, and we need to actually have this transfer of technology. When it comes to nowadays on upskilling, Shaun, it is all about upskilling yourself and how to actually transfer this knowledge to your local talent and work together with globally, how we can actually improve them. This is one of the important things where ASEAN, and not just in Brunei, we actually really need to do, to put ourselves out there in the map. And Akmal actually mentioned that it is now. We don't want to be left behind. ASEAN is always about no one is to be left behind. And we need to actually pull ourselves together and work together. Looking at low cost housing, and this is what normally people look into, right? So I'm currently doing working with Swiss Nirian Berhad on Lugu Housing, which is building 1,000 houses. And during that time, when the bidding was actually there, we already started looking into using less wastage materials, and also the fact that it's precast. You know, so it's a fast construction methodology, but again, precast is not new; it's a very old technology as well. But during the COVID time, you will also see that it does actually slow down a lot of, it also delay a lot of the things too, because you're still mixed with a hybrid of precast and also traditional way of how construction is actually being done. It's actually nice to actually see this concrete printing, but bearing in mind, concrete printing is also, you need to see the finishes inside. Yeah, Architect will actually have a lot of ideas, which is easily done by printing, to be honest with you. I mean, you look at the machine now, where you can actually print in any printing, not just concrete, any 3D printing, you can actually print parts. You can parts of your cars or your glasses, you know, those kind of things. It's more or less the same thing, you know, but it's just that it's on a bigger picture for a concrete.
So and it's a better news for the architect, in which it's closer to your imagination.
Well, the thing is, yeah, but the thing is, you see, there is a lot of raw exposure when it comes to concrete printing. So interior finishes, you still need to have it a hybrid. That's why when you actually look at some of the sample houses that actually have done, for instance, KA BINA, you can also see that there is a plastering finishes as well, which is mixed with raw finish. You also see that with what they actually did in Sarawak. It's actually a mixed hybrid of plastering, because in our region is always about finishing with a plastering finish. So, but now you actually see printing, which is raw. That's the whole idea. You know, if you can actually, people can actually accept that, then it's fantastic because it is more on really exposing this, but you can also have it both. So, I mean, those are the things that I can actually share for now on what we actually see, but it does cut a lot of the cost and a lot of the time. And that's one thing advantage for this kind of thing. Yeah.
Thank you, Your Excellency Yanty. I'll just ask one more quick question before we open the floor to a three-way communication between now Simon, yourself, and me. How ready do you think Brunei is on adopting this technology? So according to Akmal just now, the total investment that he's put in is, RM $5 million in acquiring the machine itself. So, for construction industry, it's not a huge amount. But in terms of mindset and readiness, in terms of, the capability of our people, what are your thoughts initially when you look at this technology?
Well, first things first, I guess as well is like when it comes to regulations, Akmal mentioned this as well, it is something that's new. So in terms of regulatory side, they really also have to adapt in terms of getting the occupational permit, the grades of concrete that you're going to use, because it is a load-bearing wall. We work with engineers for this Surau project, and they actually give feedback on certain things. So anyhow, you still need to actually obtain your occupational permit, like what Akmal is actually saying. They still need to actually get it basically signed off by an engineer. And the same thing as in Brunei, you really still need to work with the consultants for that, because when it comes to building any building, liabilities of and safetiness of people staying inside the house is very important. But there should also be a support in terms of encouraging from the government side, where there should be some sort of a policy where, encouraging green technology, encouraging this kind of thing to be part of the deliverables, because otherwise it's going to be so hard to actually get the buy-in from everyone. You know how the houses is in Brunei, right? So even though it's a low-cost housing, in, like, say, for instance, perumahan, there will always be a lot of extension. The moment they actually come in, because of the amount of families, we have big families, and our culture is, we're very close in terms of culture-wise. But bearing in mind, when this can actually be done, we have to bear in mind that there are certain walls, if you're actually using a concrete printing, since it's a load-bearing wall, there are certain walls that you can't actually demolish. So you actually have to be very clear on which wall that you can actually demolish and which wall you can't. This is what is being practiced as well with the current Lugu housing, that identifying, because it is a precast wall, that there are some walls that you can't actually demolish because it is a load-bearing. So these are the things that we have to be very transparent. But by the end of the day, I think having a house that is affordable is one of the most important things. Younger generation who can actually afford to build their own houses. It's timely. If we look at our housing in Brunei, it takes more than 10 years for those actually registered to apply for housing, So we can't also depend every single thing to the government. If developers can actually come in and work in collaboration with the government to actually provide this, then it is really a win-win situation. So we can actually have more buildings, more housing can actually build for the people.
Fantastic. So what I'm hearing is, if we are able to get the buy-in of the government and getting all the processes vetted, approved, safety, being overseen, it would be something that can happen pretty quickly in Brunei.
Oh, yeah. I mean, you can actually see they only need a 2-footer 40, to a container 40 footers, right, to bring in. So you actually see a rapid deployment of this machineries very fast. So it's just a matter of like getting approval to actually say, okay, whether this can actually be done, because it's not easy to actually, I mean, a transparency, talking to the research and development knowledge partners, bringing the authorities in to have this discussion. is a must. And I do hope that there is someone out there listening from the Ministry of Development or ABCI, to really look into this and have a conversation with COBOD or also KA BINA, because I think this is a really first step to actually look into it.
Fantastic. Now, I would like to, just spell out the parameters of the remaining half an hour of the conversation, in which, we have a long list of very, very practical questions from industry players on the chat room. I will address some of them, but I'll leave the final 10 minutes, for the MC to pick up some of the most important ones that we may have left out. So this would be a three-way conversation in which, any one of you can jump in to answer. But I would like to start the conversation by asking Simon. Simon, I've sent you a long list of questions, but it seems like your presentation have addressed most of them. So well done.
Thank you.
Why not? I start with something that is not on my list of questions, but that would be on the top of everyone's mind. How difficult it is for anyone who purchased the 3D printer to get up and using it right away? What kind of training is required? And who would, what kind of qualifications should I have in order to know how to operate your tools?
Okay, yeah, thank you. First of all, thank you, Her Excellency, for a great speak as well. I do share a lot of your mindset on this. I think that both as Akmal and you said, this is the time really for the technology to come in. So in terms of getting started with the technology, it's actually fairly straightforward. I think Akmal can speak into this as well, because he's actually one of the users who's gone through that journey. So basically, it's up to figuring out what size of machinery you need for the products you want or projects you want to be making. Getting that machine on order, it's produced to order. 4 months after, it will be shipped out to you in the 2 40-foot containers, as we spoke about. A combination of Akmal's team and my team will come to site, help you guys set up the machine, train in how to use the technology, and probably also in the material. If you're opting for this local concrete, we'll teach you how to do that. So basically, we're not leaving site before the team there knows exactly how to do it. Speaking into the team needed, which I think is an important thing here as well. Typically, we say you need 3 to 5 people on site, depending on the type of machine and the type of building you're doing. 2 of them should be fairly technical. One is the operator of the machine itself, so sitting with the computer to operate the technology and the whole robot. And then there's the operator of the material delivery system, which will have the recipes for the materials and the additives. This person has to be a little bit technical as well. And then 1 to 3 general workers helping on site, depending on what type of building you're doing. So that's the typical team. Maybe Akmal, I don't know if you can add on to that in your journey of getting the technology on ground.
Yeah, sure.
Akmal, I understand that you are not of construction background.
Exactly. Yeah.
And yet you are able to operate the machine.
Yep.
So it speaks volume. Please go ahead and share with us your experience.
Well, actually, all of the 5 co-founders of the company has no engineering background at all. So we come from very different other backgrounds. I'm from an accounting and finance background. The CEO is from a political science background. And the other guy is Rahman, is from a marketing background. So it's a well-diverse background, but none of it are from engineering background. But of course, in order for us to run a technology company, you would need an engineer at the end of the day. We can't operate, at the top of our head. We don't have any basis of engineering. So we did hire 2 or 3 engineers at the start of our journey. So they were the operators, basically, of the machine. Now, just to add on to what Simon has added, in terms of our experience, we believe that through a comprehensive training program that will be provided to our clients, both from COBOD and KA BINA, 1 month is more than sufficient to go through operating the machine and also to be handling the material. It's a 1 month, I wouldn't say guarantee. I mean, it's a very dangerous word to guarantee something. We do believe in terms of our experience in managing the machine, 1 month is more than sufficient to start operating by yourself and getting the hang of the material. But of course, in order to get your efficiencies, you would need more than practical experiences to go through a few developments. Then only you can achieve the efficiencies that Perry is achieving, and also COBOD themselves. Even as ourselves, we've been using the machine for the past 1 year. We can't see ourselves as experts just yet. But in terms of operating on a very fundamental basis, 1 month is more than sufficient. And just for your information, moving forward, KA BINA believes that you would not need an engineer to be on site to operate those machines. We do believe that we will have to leave that job to the technical operators. In Malaysia, we have vocational schools, right? I'm sure in Brunei you have something of a sort, where you have trade schools, training students to be dealing with constructions, bricklaying, stuff like that. So these are the jobs for those kind of people, where they will be supervised and managed by engineers. So that's the target that KA BINA has for the practical application for 3DCP in the market. So rather than having engineers, because sometimes, of course, engineers, we know they like to sit on their computers rather than being on site and handling the machines themselves. So we are playing with that narrative, whereby, of course, for the start, we have engineers, but moving forward, it will be passed on to the technical operators, the trade suppliers. The engineers will just observe, monitor, and supervise. So I think that's where we are heading, and that should be the direction of where the industry is heading.
It gives me so much hope.
Yeah.
Can I, Shaun,
yes,
can I actually add up as
yes.
well with regards to this? It's really interesting. It's because for construction, 3D printed construction, you are not actually dealing with the normal traditional team player. Like normally we have engineers and also, M&E, CNS, but you also deal with IT engineers, so you actually bring in really the great minds in this kind of field. But also bearing in mind, of course, authority, compliancy is a must. So I also foresee that doing this kind of project, it is a front loading. So you do a lot of your design on your front end, because you must know where your table will come in, because you actually have to put in your conduit first before your layers and layers of printing comes in. Because again, bearing in mind, you're not going to hack after, you missed a point. So everything, if you actually use the building information modeling, whether it's a BIM or whether it's SketchUp, everything has got to be integrated. Structural components, if there is, the mechanical or electrical, with actually where your power point is, where your switches is going to be. Everything is actually needs to be in the front loading, which is good, because you are not supposed to be making that much mistakes when you actually start printing. And that's the reason why you only need the technical people to run the printing itself. But when it comes to the whole design, you really need the team to actually be putting more effort to make sure that it is a complete design. Thanks, Shaun.
So the level of professionalism and forward thinking, forward planning has to be immaculate, because it's not like the traditional kind of construction process whereby, you can change your mind and then you can hack, you can do all kinds. So flexibility is a two-way thing, isn't it?
Yeah, well, so just to add to that, I mean, this is a force of the technology, right? That you can actually do all this planning beforehand, before you go on site. Everything is exactly as it should be. If you want to hack and slash the walls afterwards to do your things, you can also do that. But the conventional ways, right? But I think that it's really the big force, as I talked about, the Perry projects. They save 70% of time of the other trades afterwards, which is basically cutting the time to market for this house, right? And what we've been speaking so much about today is that we need a lot of houses for people and in a short amount of time. So I think it's really a good point, Her Excellency, in terms of front loading all this work into the design phase, so that we have the smartest design possible that will actually ease everything up afterwards. Great.
Fantastic. Akmal, I'd like to come back to you. From your background as an accountant and a financial person, all of us here who have been listening to the both of you for the last 50, 60 minutes are very excited about this technology. Walk us through your thinking process in terms of investment and return on investment on this endeavor. What are your thoughts when you started this business?
Sure. I think that's actually the number one question that we've typically had from prospect clients. They always ask, what's the return on investment on this machine? So
yeah, when is it
that's
the
all.
break even? Yeah.
That what's the break even and stuff like that. So it's difficult. I mean, I'll be very transparent and very honest with you. It's very difficult for me to answer this question simply because KA BINA itself, we've only had one project, right, that we've done, which is the first house 3D printed in Kuala Lumpur. And I do believe that, I mean, to be fair to the technology, it's not a good reference point since it is our first 3D print. There were a lot of mistakes, you know. It was also during the time where we are material testing. So the amount of materials that we had to throw away, for example. So that's also factored into the overall cost of developing that house. So just to give you guys an idea, the house cost us in terms of its construction for everything, the foundation to the walls to the roof, it costed us around 160,000 ringgit for a mere 1,300 square feet house, a bungalow. So that puts you at about 139.29 ringgit or 130 ringgit per square feet. Now, if you are targeting for affordable housing, at least here in Malaysia, the amount must go lower than 100 ringgit per square feet. So again, just to answer on the cost side, of course, the first house to be 3D printed is not a good reference point, but we do believe that as you know, you are more experienced in the technology, you can achieve the efficiencies that you would need. I'll give you an example. The house that we were 3D printing, it took us 23 days to complete the printing of the house, whereas in actual fact, the house only needs 40 hours to print. So based on the slicer software, right, as I've mentioned earlier, it indicates how long it would take, how many layers, how many materials you would need. Only 40 hours. Now, had we managed to achieve those numbers, you can expect the house to be completed in just under 8 days. Now, that is going at a very conservative speed. The printer has variable speeds. You can go fast, you can go slow. The 40 hours is if you're going a very conservative speed, which is 10 centimeter per second. We've actually gone up in our printing process up to 27 centimeter per second. So it's more than double the speed. So if, for example, you've managed to achieve the level of experience, then you can achieve, printing 1,300 square feet in under 4 days. Now, to answer your question, Shaun, in terms of the payback period, the ROIs, it depends, right? Number one, the level of competencies your users or the company has on the machine. Number two is, of course, the type of developments that you're targeting. Again, we are not simply talking about housing. If, for example, the company uses the technology to develop concrete furnitures, for example, that's a huge market today. We've been talking to clients all around in the region. They want to develop, barriers for flood, for example, 3D printed barriers using concrete, and even coral reefs. We've had discussions on those things. So it depends on the final product that you're trying to 3D print. And we don't have necessarily the data to support saying if you're using conventional, how much will it take for you to develop the barriers. I mean, we as a company, we do not have those data because we don't delve ourselves in those things. But of course, it depends on those two things. Number one is the level of competencies your team has. Number two is the type of products that you want to achieve. And just to give you an example, if you can save, we do believe conservatively for the house that we are printing, we could have saved more than 30%. Of course, that one is as much as we believe because the waste that we've generated is around that much when we were printing the first house. So if you can achieve 30% of saving and in terms of time and speed, then it will factor in terms of the overall cost, and you can expect to achieve the payback period quite significantly. And bear in mind also one last thing, just to put as a caveat here, KA BINA is a very small company. We only have 3 engineers currently operating the machine. We are not huge, large-scale developers. Like, for example, companies or audiences that are here, you have a team dedicated, a very experienced team. The oldest guy in our company is actually only 30 years old. So it's a very young team. So that's where we are coming from. And we do believe that the younger generations will take up the mantle. But of course, having experienced partners to take on the technology will definitely achieve the efficiencies that you achieve, definitely.
What gets me really excited about this is, you're the pioneer in Malaysia, and according to the weather, Southeast Asia, pretty much the same.
Yeah.
And you were referencing upon a country in Africa when you implemented your first project. It can only be a lot more efficient and cheaper if we were to learn from your mistake.
Exactly. And that's where we are coming from, KA BINA, right? We provide consultancy and training for clients that are taking up the technology and using the material. We will give you all of the learning curves that we've had. You don't have to start from scratch anymore. We've already developed the working recipe. You'll get it for free. I mean, you can work on it, no problem at all. So you will avoid all the obstacles that we faced for the past 1 year. you'll get a head start lah, basically. So I think that comes with experience, and that's where KA BINA comes in. We don't want to become full-fledged contractors or developers ourselves. We want to provide this technology for the market to be able to adopt this with ease of use. So that's our target, and you're right.
Right. Simon, before I ask you this question, right, I'd like to invite both Simon, Her Excellency Yanty, as well as Akmal to look at the chat question and shortlist some of the best questions that you want to respond to after this, right? We have, less than 15 minutes left. My question to you, Simon, is this. From a layman's point of view, when we look at technology, it is only going to get cheaper. It seems that there is some teething process for one to become a lot more efficient at the beginning stage. What is the incentive of me, being a big company like SWE in Brunei, or, any first, what is the first mover advantage over, waiting for another decade for this to mature, for the price to load down before I invest? What are your thoughts on that?
Got it. Thank you for that question. So basically what I think is that this is a beautiful time to actually look into new technology. As we've heard today, we're in need of new houses in a quicker manner. The learning curve we've learned about today as well is, of course, something you have to factor in. But you see, it's during the first project you are tripling your speed in terms of how you're doing. So it's not like you have to use the technology for 5 years before you are reaching these levels, right? And the beauty is here, Akmal has a lot of learnings with his team. These will be directly transferred. COBOD Connect, as I talked about in the end of my presentation, is a platform where you can meet all the other users of COBOD machines around the world. You can ask any questions openly in the forum, get the help from all these guys to really utilize the technology in as quick a manner as possible. So already with the speeds and the material we see today, there's a huge potential if you just put in the first, let's say, quarter to actually master the technology, get it on ground, master the technology, and go out there and do it. It might be in housing, it might be in other structures. I think the first mover advantage of actually getting the technology now is key. One other thing you will get is that if you start searching in construction magazines around the world, a lot of our customers have actually gone to be kind of rock stars, right? Because they are the first ones to actually bring in the technology. So a lot are using the technology also as both a stepping stone towards a brighter future in how they can deliver homes or structures, but also as a way to show that they are on board with new technology. And it's really, it's dragging a lot of press these days. So that's for sure.
So it's well worth paying a slight premium to get yourself out there.
And to be honest, Shaun, I don't even know if it's a premium. If you look at the price of our machine compared to a crane or other construction tools, it's a construction tool, right? It's kind of the same level as all these other tools. We don't factor in a lot of extra premium in this. It's a high quality machine made to last you the next 5 to 10 years, depending on your willingness to maintain, of course. It's in high grade steel, all of it with the highest level components from Omron and so on and so forth. So it's a quality piece of machinery that will at least hold you until the 10 years that you said you wanted to wait before. So
okay, before I open for you all to pick one question each, one important question I thought should be addressed is the durability of the houses being printed by a 3D machine. Is it going to have as long a lasting effect as a traditional traditional built house?
So can I answer?
Yeah, that's for you, Simon.
Thank you. So I want you to look at it like this. So we said we are open sourcing material, right? Depending on the material you put in, it's a concrete wall of that material. That's exactly what it is. So a cast material like the same would be of the same standard. So look at it as a cast concrete wall. The material guys from our side will come down and make sure that the mix you're using is making uniform layers, meaning that if you cut through the wall, you'll see that all the layers are totally monolithic, meaning that they are all together. So you can see it as a concrete wall and compared to the live length of that.
So it's dependent upon the materials that you use.
Yes.
Okay.
But I mean, as a concrete wall, it's a long lifetime wall, especially if you maintain it well, paint it, then you'll have a house for many decades.
Fantastic.
Yeah.
Akmal, do you have a favorite question that you want to address?
I think I think I can see that a lot of repeating questions is on how do you do plumbing and electrical services in the house, right? So there's actually two ways. The one of the ways that we did was with our first 3D printed house in Kuala Lumpur is we had a double wall system. It means that you have a outer wall, an inner wall, and a cavity in between. So the way that you would lay out the services is through that cavity that you would have. And of course, I think Her Excellency mentioned that the bulk of the planning of the house is at upfront, right? So that when you are designing the house, the electrical services have already been factored into where it's going to run and stuff like that. So, having that in mind, so as you are printing, you already have the cavity and you would know already, you've communicated with the contractor, these are the plug points that you would like to have. So that's, and also even if you're doing the plug points or if you want to do the plug points, right, there's two ways to do it. One, either you input the cavity or the places where you want to put your plug points inside the drawing, or the other way that you can go about it is print as per normal. You don't have to input the because the concrete hardens after 1 hour, right? So you have about 1 hour window for you to simply cut through. So it's very manageable. I've actually cut with a brick knife myself, just to test out the easiness of trying to remove the concrete. And I did that, and I simply put in a polystyrene foam, so as a supporting, as the upper layers are being printed. So that's two of the ways that you can achieve cavity to build the cavity. Of course, if you want to save money, input that inside the design of the house earlier on, so you don't have to cut anything, but you do need lintels and stuff like that. So again, in terms of services, that is one of the ways you can do it. Put it in between the outer wall and the inner wall, the cavity. The second way for you to do it, which we've observed a client in America did it, they printed one single wall, a 10 centimeter wall straight up. And for the areas that have the services run through the walls, they would cut it afterwards, put the services in, and then they simply plaster it. So that's another way for you to do the servicing, the services for the house that we've observed. So I think it is quite straightforward. So yeah, I think I hope that answers.
Right.
Yeah.
Simon, I'm going to pass you the time right now. But before that, because all these questions are very technical, I would like to invite, after your comment, Her Excellency Yanty to provide a final remark. And perhaps, Your Excellency, you can think on the question on, what market opportunity there is.
Then you pass by.
So,
we pass.
Give me, yeah. Okay. So let me repeat that. Yeah. After Simon's comment, I will invite Her Excellency Yanty to comment on the kind of market opportunities that she foresee 3D printing has for Brunei. So over to you, Simon. What is your favorite question that you like to address?
Great, thank you. I think there's so many good questions, Shaun, but I picked out one here, which I think is important to look at as well. So it's from Mustafa saying, what new skills are required in the architect to design printable structures? I think that's a very important thing to address as well. So the slicer that we have was shown earlier. The slicer is basically the software taking it from the engineering or architect drawing to a printable file. This one takes step files, which is a standard export from most CAD programs, meaning that you'll design in the way you usually do. Then depending on what software it is, one of the biggest ones is Revit. We have a plugin directly for that will link into our slicer. SketchUp or Rhino can be used also exporting the step files that we need. We will make sure that our customers knows exactly how to export in the system that they're using today. So it's a very limited number of softwares that cannot do this, and they can do it via some conversion at least. So I think that was important to put a point to.
Fantastic. So we have final 3 minutes. Over to you, Your Excellency. What market opportunity do you see in this 3D printing?
Thanks, Shaun. So if I can actually combine this question with regards to, because I'm such a very technical person to, unfortunately I am in the industry, but I would just like to add on with when it comes to technical. It's always great to work with our younger generations. I mean, Akmal, your background with accountant, I believe, and your team is not even an engineers, because they are the game mover. They move things. I mean, Simon, you've got your experience too. I mean, I've heard and worked with even economists who actually have on a different background that is related to architecture, because they're using a lot of digital technology. So from our side as professionals, we also have to adapt and work very closely with this game mover. You move very fast. So we have to move fast too. And to be able to really understand, but also ensuring that we have to actually comply with regulations. And Brunei, we do have our PBD 12, do's and don'ts, especially where the power socket is. Can you actually put it very close to the water area? Those kind of things. So and also fire requirements is something that we have to comply. And working together with professionals is good, because then you will actually see, safety of the end user staying in the house. We have to make sure that we comply. Liabilities is very high. But again, we're very open to any technology when it comes to construction industry. And this is really important, because by the end of the day, the product is for the homeowners who actually wanted to purchase a house that is affordable for them. Those who is in the low income or middle income who can't actually afford a very expensive houses, they need to still sort financing from either the bank or from the government loan, those kind of things, and they can only afford that much. So we have to bear in mind that it's not about massive kind of structure. It's all about giving them a safe home that is for their family. And younger generations is somewhere we actually say is priority as well, for them to actually be independent and have their own place. And housing, low-cost housing in Brunei, the way I see it's still a huge market here. And with all these good technologies and bringing the cost down and shorten the time of construction, it is such a huge advantage. And it is a win-win for everybody. And we are just so happy if we can actually get more of our low income, especially youth and generation, can actually have their own homes. That's my feedback. Shaun.
That's a piece of good news. Wouldn't it be cool for all the young generation to say, I'm living in a printed property?
Yes, definitely.
Hani, over to you. I'm very sure that there'll be a lot of inquiries and people wanting to partner with Akmal and of course, Simon. How can they get in touch and where to from here? Thank you so much to AITI for this fantastic opportunity for the whole industry to learn about this amazing opportunity. Thank you to all three of our excellent panel speakers.
Thank you again to Simon and Akmal for sharing your insights on how COBOD and KA BINA operates. I saw a lot of wins there, so congratulations on that. I would like to express my appreciation again to our special guest speaker, Her Excellency Architect Siti, for sharing to us the areas where Brunei can move forward in terms of our construction industry. Appreciate you too, Shaun, for moderating it as well. I hope this audience will leave this webinar with a little bit more information. But before that, I will now be giving the mic to Yang Mulia Muhammad Nur Ilham bin Haji Zaini from AITI for this event's closing remarks.
All right, thanks, Hani. Thank you to our speakers, Simon, Akmal, and Her Excellency Architect Yanti, for the informative and insightful session, and also to our moderator, Shaun. Construction giants are quickly realizing the potential of 3D technologies and their impact on the future of constructions. More and more companies are starting up in the sector to create new innovative projects. Some are more futuristic, some are very in the present. Construction 3D printing is developing rapidly and relies on different technologies and materials, offering many benefits to its user. Again, thank you to you all, and your participation is very much welcome. I hope everyone was able to have some fruitful takeaways, and last but not least, stay safe and stay healthy. Now I shall pass back to you, Han.
Thank you, Yang Mulia Muhammad Rahman, for your speech. We have come to the end of the seminar. Thank you again to AITI for this opportunity to expand our knowledge on 3D printing for the construction industry. With that, Assalamualaikum warahmatullahi wabarakatuh, and have a great day. Thank you again for attending.